The robot tries to have a wall that's right at all times. It always turns left unless it's reacting to green, red or blue. It uses the depth image from the Kinect to detect walls, so it can stop and turn before it runs into something. It also uses the BGR image to detect the coloured panels throughout the maze. Red and green are only detected when they're close, because the panels can sometimes be seen through walls, and they can cause the robot to move incorrectly if they're spotted too soon. When red is seen, the robot stops and turns left, then resumes normal behaviour as if the red was a wall. When green is seen, the robot moves towards it and stops once it can no longer see it. As you just saw in the video, when green is spotted through a wall, the robot will stop incorrectly. Blue is only detected when far away, because getting too close can cause the robot to swap walls, meaning the robot ends up travelling in the wrong direction. When the robot's close enough to blue, it can no longer detect it and it continues normal behaviour. Colours are detected by first converting to HSV, because this colour space can better separate colours from shadow. Restricting the detection of colour by distance is done by creating a binary mask for both colour and depth, and then combining them using bitwise AND. When there are no walls or colours within the appropriate ranges, the robot moves in an arc such that it moves safely around the edge of a wall. The robot's movement is largely based on centroids of detected objects. For example, when blue is spotted, the robot turns so that the centre pixel of blue is in the middle of its field of view. When a wall is seen in the depth image, instead of moving so that the centroid is in the middle of the robot's vision, it turns until the centroid is at the very edge, keeping the wall on the right. The amount the robot turns is proportional to the distance between the centroid current position and where it should be in the image. When it's moving along a wall and the space in front of it is clear, the robot moves twice as fast. The robot's output is published to a new ROS topic, which is then read by a different ROS node and displayed to the console, as you can see in the video. NaN is used in the depth image, where the distance is outside the scope of the camera. The amount of NaN pixels in the image is used as a metric to determine when the robot is against a wall, as the distance from the camera to a wall when the robot's bumped into it is returned as NaN.